Hello everyone. This video is for the week of May 4th to May the 8th. In this video, we will be talking about section 7.3, special angles. This section is very important in this unit and as well as for grade 12. So you guys have to understand this. Okay, so let's get started. Okay, before we start the special angles, we need to review for some of the concept first. So if you guys remember this diagram here that we talked about, this point here is a point on the terminal arm of our angle theta. So we know that in order to calculate the three trig functions, sine, cosine, and tangent, sine, cosine, and tangent, we'll need to construct a vertical line to the x-axis so that we have a right angle triangle, correct? And we know from last time that the opposite side of our theta here is y. The adjacent side of our theta is x, and the hypotenuse is this one. Let's use r to represent the hypotenuse. We know that hypotenuse is equal to square root of x squared plus y squared by Pythagoras theorem. Okay, now let's talk about the three trig ratios in terms of x, y, and r. So cosine theta is equal to opposite over hypotenuse, where opposite is y and hypotenuse is r. Cos theta is equal to adjacent over hypotenuse, so that will be x over r. And tangent theta is equal to opposite over adjacent, so that will be y over x. So these are the three formulas that you guys will need to understand and memorize. You will see this a lot for the next few sections and in grade 12. Just make sure you don't mix them up. All right, now let's talk about quadrantal angles. A quadrantal angle is an angle whose terminal arm lies on either the x-axis or the y-axis. And these angles are the easiest special angles that you can calculate for their three trig ratios. So let me give you a few examples of quadrantal angles first. So let's say this angle here, angle theta, which is equal to 90 degrees, is a quadrantal angle because its terminal arm, the red line, lies on the y-axis. Another one, this one, angle theta is equal to 0 degrees, and it's also a quadrantal angle because its terminal arm lies on the x-axis. And so we know that this one, the 180 degrees angle, or this one, the 270 degrees angle, would also be quadrantal angles, right? And of course, we can have this one, 360-degree angle. Okay, so basically, any angle that is a multiple of 90 degrees. Okay, so any angle that is a multiple of 90 degrees is a quadrantal angle. Now, how do we calculate the three trig ratios for a quadrantal angle? Let's use 90 degrees as an example. So we can find any point on our terminal arm. Let's say this point here. And the easiest point to calculate will be the point 0, 1. The x value is always equal to 0 because the point is on the y-axis, which is the y-intercept. So x value is 0. If you don't like 0, 1, you can try other point. So something like this. We can do 0. We can do 0 and y. Doesn't matter what the value of y is. But for now, let's just use 0, 1 as an example first. So we know x is equal to 0, y is equal to 1, and r is equal to the square root of x squared plus y squared, which is at square root of 0 squared plus 1 squared. So that's square root of 1, which is 1. And remember that r is always positive, so we don't need to do the -1 part of it. Okay, and we know sine is equal to y over r from the previous page. So y is equal to 1 and r is equal to 1 as well. So sine 90 degrees is equal to 1. And let's do cosine. Cosine x is equal to 0. Oops. Cosine is equal to x over r. And x is 0, r is 1, so this is equal to 0. Tangent 90 degrees is opposite y over adjacent x. So that will be 1 over 0, which is what? Undefined. You can't have something over 0. You're not allowed to divide by 0, remember? So we know for 90 degrees, the sine ratio is equal to 1, cos ratio is equal to 0, and tangent ratio is undefined. Okay. If you guys wonder if the three trig ratios are the same if you're using another point on the terminal arm, I'll tell you that they are the same. So let me do 0y as an example to show that. So if I'm using 0y, then x is 0, y is just y, and r is equal to x squared plus y squared, which is equal to 0 squared plus y squared, and that's square root of y squared, which is just y, right? So then our sine ratio, sine 90 degrees, is equal to y over r, which is y is just y and r is y as well. So sine 90 degrees is equal to 1. And cos 90 degrees will be x over r, which is 0 over y, which is 0. And tangent is the same. I just don't have enough space to write it. So here we know that doesn't matter which point we use on the terminal arm, the three trig ratios will always be the same. Okay, let me write that down here. The trig ratios only depend on angle, not the length of the sides. Okay, so the trig ratios only depend on the angles, not the length of sides. So again, doesn't matter which point you use on the terminal arm, they will always give you the same answers. Let's do another example just to practice. Let's say this time our angle theta is equal to 180 degrees, and we can choose a point that's on the terminal's arm of this angle. And I found that the easiest one is -1 and 0, because it's one of the x-intercept, so the y value is always 0. And the easiest point to do is 1 unit away from the origin, so that point will be -1, 0. You guys can choose another point if you want. So let's just write down the three values. The x value is -1, y value is 0, and the r is equal to the square root of x squared plus y squared. So that's 1 plus 0, which is 1. So let's find out what sine 180 degrees is equal to. Sine 180 degrees is y over r, which is 0 over 1. So we know it's equal to 0. What about cos 180 degrees? That would be x over r. So -1 over 1, that would be -1. And tangent 180 degrees is y over x. So that will be 0 over -1, which is 0. Okay, so the four easiest points that you can use to find the trig ratios for quadrantal angles are these four. 1, 0, 0, 1, -1, 0, and 0, -1. Whenever you have a quadrantal angle, just use one of the four angles depending on where your terminal arm is. Next, we'll talk about the three special angles: the 30-degree angle, the 45-degree angle, and the 60-degree angle. They're called special angles because we can calculate the trig ratios for these angles in exact values. Okay, so the trig ratios for these angles can be calculated in exact values. Okay, let's consider the 45-degree angle first. In order to calculate the three trig ratios, we'll need to have a right angle triangle, right? So let's draw a right angle triangle that has a 45-degree angle in the triangle. So this angle is 90 degrees and this one is 45. That means the other one have to be 45. So here we have an isosceles triangle, meaning that these two sides are the same. Okay, and we know from the previous notes that the trig ratios does not depend on the length of the sides. It only depends on the angle. So why don't we just make the sides, the two equal sides, equal to 1, because 1 is always the easiest to calculate. Okay, so if these two sides are equal to 1, then what is the hypotenuse equal to? The hypotenuse is equal to 1 squared plus 1 squared, which is equal to 1 plus 1, so square root of 2. Okay, and let's calculate the three trig ratios for this angle. Okay, and we use maybe this angle to be the angle that we're calculating for. Then sine is equal to opposite over hypotenuse. The opposite for this highlighted angle is this one. So that'll be 1 over hypotenuse is root 2. Cos is adjacent over root 2. So it'd be this. side here, which is 1 again over root 2. And tangent is equal to opposite over adjacent, which is 1 over 1, which is still 1. Okay, so we know that sine 45 equal to 1 over root 2, cos 45 equal to 1 over root 2, and tangent 45 equal to 1. And this is our 45-degree angle. Okay, now let's consider a equilateral triangle with all sides equal to 2. And we know that for equilateral triangles, all of the 3 angles are equal as well. So 180 divided by 3, each angle will equal to 60 degrees. Okay, so let's make a line through the middle here. This is the height of this equilateral triangle. And we know that this angle is 90 degrees. And so what's this one? 180 minus 90 minus 60, this angle will be 30 degrees. And so the height cuts the bottom side into 2 equal parts. Each part is equal to 1. Okay, so let's take the left triangle out. So this is 1, this is 2, this is 60 degrees, this is 90 degrees, and this is 30 degrees. So we have the hypotenuse, we have the bottom side, and what's the vertical side equal to? This side is equal to the square root of 2 squared minus 1 squared by Pythagoras theorem, which is 4 minus 1 square root of 3. Okay. Now let's consider the 3 trig ratios for 30-degree angle and for the 60-degree angle. So let's do maybe 30-degree angle first. Sine 30 is equal to opposite over hypotenuse, that's 1 over 2. Cos 30 degrees is equal to adjacent over hypotenuse, so that's root 3 over 2. And tangent 30 degrees is equal to opposite over adjacent, that's 1 over root 3. Now let's do sine 60 degrees. Sine 60 degrees is equal to opposite over hypotenuse. Cos 60 degrees is equal to adjacent over hypotenuse. And tangent 60 degrees is equal to root 3 over 1, which is just root 3. So here. For this section, you can either memorize this chart, which is a summary of the trig ratios, or you can memorize these 2 triangles that can help you to calculate the trig ratios. For me, I like to memorize the 2 triangles because I felt that I may get messed up with these numbers because they look really similar to each other. So I don't really like to memorize these. You guys can do whatever you want, but I would recommend to memorize the triangles. The first 20 minutes of this video is about definitions and concepts. Now we're going to do a few examples just to see how we can really use that knowledge to solve problems. Example number 1. Evaluate sine 210 degrees. Let's draw a diagram first to see where 210 is. Okay, 210 degrees is between 180 and 270. So it will be at the third quadrant. So this is your angle theta to 110 degrees. And if you remember from the last video, in order to calculate the trig ratios, last time we drawed vertical lines to make right angle triangles. And the angle that we're using is this angle, right? And if you remember that this is the reference angle, okay? And our reference angle on the third quadrant is equal to 210 minus 180 degrees, which is 30 degrees. And from last video, we know that we're using reference angles to calculate the trig ratios. So instead of calculating sine 210 degrees, we will be calculating sine 30 degrees first. Okay, now we know that 30 degrees is a special angle. You guys can either use the chart or you can use the special triangle. So for this question, I'll be using the special triangle. 30 degrees is here. This one is 60. This is 90. And the longest side is the hypotenuse, 2, root 3, and 1. And sine 30 degrees is opposite over hypotenuse, which is 1 over 2. So we know that sine 30 degrees is equal to 1 over 2. But our question is sine 210 instead of sine 30 degrees. Even though their values are the same, but the sign will be a little different. Because we know that sine 30 degrees is positive, but sine 210 degrees, because it's in the third quadrant, ASTC, because it's in the third quadrant, the sign is negative. So instead of a half, sine 210 degrees will equal to negative a half. Okay, let's do another one to practice. Evaluate cos 315. So let's draw the angle in standard position first. 315 is between 270 and 360, so it'll be at the fourth quadrant. Theta is equal to 315. And we need to know the reference angle in order to calculate the trig ratios. So this theta prime is equal to 360 minus 315, which is 45 degrees. So let's calculate cos 45 degrees first. Okay, 45 degrees. This is root 2, this is 1, this is 1. Okay, so cos 45 degrees is adjacent over hypotenuse, which is 1 over root 2. And to calculate cos 315 degrees, we need to know whether it's positive or negative. We know that it's A S T C. So in the fourth quadrant, cosine is positive. And the answer will be the same as cos 45. Okay, here is a summary of how to calculate the trig ratios. First of all, we need to draw a diagram showing the angle in standard position, so we know where the angle is. Okay. Second, we need to find the reference angle, angle prime. After we find the reference angle, we need to calculate the trig ratio for the reference angle. Okay. Then we'll need to use this chart, ASTC chart to determine the sign of the actual question. Okay, this question is a little different from the two we did. In this question, it asks you to find the angle given the sine ratio. Okay, so the question is to find all angles such that sine theta is equal to root 3 over 2 and that theta is between 0 degrees and 360 degrees. If you look at this sine ratio here, does it look familiar to you? We know that root 3 and 2 are two sides in our special triangle, right? So it's 2, root 3, and 1. This is 30 degrees, this is 60 degrees, and this is 90 degrees. Okay. Now, which angle will have a sine ratio of root 3 over 2? We know that root 3 is the opposite. Which angle has an opposite of root 3? This one, right? 60 degrees has the opposite of root 3. So we know that sine 60 degrees is equal to root 3 over 2. Okay. But the question is not only this. The question asks you to find all the angles that satisfy this condition. Okay, so let's see. In standard position, we know that 60 degree is our reference angle. And when is sine positive? ASTC. Sine is positive in these two quadrants. Okay? So it's either in the first quadrant or in the second quadrant. If it's in the first quadrant, then theta is equal to 60 degrees. If it's in the second quadrant, where this angle, angle theta prime is equal to 60 degrees, then your actual angle is equal to 180 degrees minus 60 degrees, which is 120 degrees. Now, the angles that are in quadrant 3 or quadrant 4 will not work. The reason is that for angles in quadrant 3 and quadrant 4, they are negative. But in the question, sine theta is positive. So we don't consider the angles that are in quadrant 3 and 4. This section is not easy, so we'll do a few more examples. The next one we're going to do is very similar to the previous one. So to find all angles such that tangent theta is equal to negative 1 over root 3 and theta is between 0 and 360 degrees. Again, let's just take a look at this trig ratio here. Tangent is equal to negative 1 over root 3. Does 1 and root 3 look familiar to you? So you can use the chart or you can use, again, this special triangle. Root 3, 1, and 2, 30 degrees and 60 degrees. Okay, we know that tangent is equal to opposite over adjacent. Which angle has an opposite of 1 and adjacent of root 3? We know that this 30-degree angle here has an opposite of 1, right? So we know the theta, our reference angle, must be 30 degrees because tangent 30 is equal to 1/√3. But now the question is tangent theta equal to negative 1/√3. So again, let's draw our standard position first. A, S, T, C. Where is tangent negative? Tangent is negative when it's at the second and the fourth quadrant. So we know that our angles must be in the second and the fourth quadrant. Let's draw that. It's either this one or this one. This is your reference angle. So your actual angle then it's this one and this one. Okay. Let me use a different color maybe. So the smaller angle is equal to 180 degrees minus 30 degrees, which is 150 degrees. And the larger angle is equal to 360 degrees minus 30 degrees, which is 330 degrees. So you got two answers. One is theta equal to 150 degrees, and the other one is theta equal to 330 degrees. Okay. So to do questions like these, always find the reference angle first, and use your standard position to find the other angles. Here is a summary of finding angles given trig ratios. First step, we'll need to find the reference angle using the chart or the special triangles. And then we'll need to determine which quadrants the actual angles are in using the ASTC chart. Okay. Last, draw the reference angle in those quadrants in standard position, and then find the actual angles. Okay, one last example. Find the smallest positive angle such that sine theta is equal to negative 0.7111. Now, if you look at this trig ratio here, you can see two parts. One is the negative, and one is the number. Okay, each of them tells us something. The negative part tells us the quadrant. And the number part will help us to calculate the reference angle. We can calculate our reference angle using the blue part. Okay? So, again, ASTC. Sine theta is negative, means that the angle is in the third or the fourth quadrant. Okay, so we know that it's in quadrant 3 or quadrant 4. Okay, now let's use the blue part to calculate the reference angle. So we know that sine reference angle is equal to 0.7111. The trig ratio of reference angle is always positive. So when you are calculating reference angle, always remove the negative sign. Okay? So theta prime then is equal to arcsine of 0.7111. You guys know how to calculate this on your calculator, right? It's shift and shift key and the sign key. press shift and press sign, then press 0.7111, you'll be able to get theta. So theta here is equal to 45.3 degrees. Okay, why didn't we use the special triangles or the chart this time? Well, because 0.7111 is not one of the ratios that we see in the chart or in the special triangles, right? So this one doesn't really give you a special angle. So we don't use the special triangles or the chart. Okay, now let's find the angles in standard position. We know that it's in the third or fourth quadrant, so it'd be here or here. And the reference angle is 45.3, 45.3. So our actual angle is this one or this one. The black one is 180 plus 45.5, which is 225.3. And the blue one is equal to 360 minus 45.3 degrees, which is 314.7 degrees. But if you look at the question, it only asks you to find the smallest positive angles. If you consider these two angles, which one is smaller? The black one, right? So our final answer is just the black one, where theta is equal to 225.3 degrees. I didn't do too many examples in this video because I got complaints about the length of the videos. But I do think that this section is very important. So please spend some time and do the workbook questions just to get more comfortable with the concepts and the problems. And I'm always happy to take your questions. So please post your questions on Teams or ask any questions during the office hours on Thursdays or Fridays. That's it for today's video. Bye everyone.